Section 1.1 is functions, and there are 4 representations. So the first thing we're going to start with is exactly that right there, the 4 ways that we are going to represent functions. So the first way is numerically. Now, this language you need to know. So when somebody says numerically, you need to know that that means you're talking about a table of values. Okay, it's a table. If it's talking about algebraically, you're talking about an equation. You know, y equals mx plus b, equations. Verbally, it's given in language only. It's a description of some sort. So there's no numbers in it per se. It's a language description. And then graphically, where it is given in terms of a graph. And these are the 4 ways that we can represent change, which is part of representing functions. Now, before we can actually get to functions, we have to talk about what a relation is. A relation is simply a statement that links one quantity or variable to another one. Okay? A relationship. The input is the variable put into an equation, and then your output is the variable coming out of an equation. And then when we specifically go from relation at the top to function at the bottom, we have some extra conditions. A function is a type of relation where each input corresponds to exactly one output. So an example of a function, I'll use a verbal description of a function, would be this. Every person in this room has one and only one biological mother. The input is you. The output is your mother. Make sense? You can't do that with siblings, right? If you are the input and I say that the output is your siblings, some of you may have one and only one, and some of you may have 0, and that would be okay, but some of you may have multiple siblings, and that would fail to make that a function. Okay, one input gives you one output. Function notation is f of x, and that's how we read it, f parenthesis x, where x is the input and f of x is the output. And we often think of that notation, f of x, as being y. So you'll see things written sometimes like this. Right? You input an x, you get back a y. So we're going to use the notation that if we input an x, we get back an f of x. A unit of measure is a word or a short phrase telling how a variable is measured. For example, if I ask you how tall you are and you say 5'4", what is the unit of measure that you think I'm using? Feet and inches, right? So if we were traveling somewhere else and you used a unit of measure, especially if you were outside of the United States, it becomes more crucial to identify what that unit of measure is because I measure something in feet and you're thinking meters and we all of a sudden have a disconnect, right? So the unit of measure, specifically in this class, is going to be extremely important. Virtually every answer you write down is going to have some kind of unit of measure with it. And it won't necessarily be things like feet and inches. It might be people, right? Stuff like that. So it doesn't have to actually be measurements. All right, so here's an example of a function. A student's raw score on a spelling test with 20 evenly weighted questions can be expressed by the function g of n equals 5n when she spells n words correctly. All right, so your book really likes to use different letters than just x and f of x. Go ahead and start trying to get accustomed to that and be okay with it. They in particular like to use letters that represent the quantity that they're describing. So you see them using n as their input because they're saying n is a number of words. That's what they're doing, okay? Now, if you want every time you write one to use f and x, and f of x, that's fine, doesn't hurt anything. But just be aware of the fact that your book's going to continually use different names for things. So this g of n equals 5n is the same thing as saying f of x equals 5x. There's no difference. All right, it says to identify the relation as numerical, algebraic, verbal, or graphical. So it says it can be expressed by g of n equals 5n when she spells n words correctly. Which type of relation is being used to describe that? There's a catch on the verbal. It's algebraic. The catch is that verbal has to use no numbers in it. So if you take a look back over here, it has the word only in it. So if we described it in words without the equation itself, it would be verbal. But this one is algebraic. Okay, does anybody have any questions about that? It's algebraic because there's an equation. That's why. All right, so we're going to just state the description and units of measure for both the input and the output variables. So in order to do that, we first need to identify what the input and output are. So in terms of the variables or letters used, what is the input variable? It's n. And what is the output variable? G of n. Okay, those are our input and our output variables. Now it said to state the description. So what is it? It's a number of words, right? It's words spelled correctly. What is the output? It's the what? Not quite. It's the raw grade. It's the grade you're getting from the questions. Okay, so there's 20 of them. So what would happen if we got all 20 of them right? You get 100. That's why the 5's there. Okay, so it's multiplying to give you the score. So it says it is the raw score right up here. So this is the raw score on the spelling test. Okay. So those are the words that describe what's going on, the description, if you will. And then the unit of measure would be what we've already actually written it, so I won't write it again, but it's words here. That's our unit of measure. So when I tell you n is 5, it means you spelled 5 words correctly, right? 5 words. And then this is your raw score. The raw score is the unit of measure, if you will. It's the grade that you got on the test. Okay, so those are inherently listed in the description that I just gave. Does that make sense? All right. It says to indicate whether the relation is a function. Okay, so we just talked about this. What does it mean if it is a function? What condition must be satisfied?
There's only one output.
One output for one input, yeah. So when I put one number in, I will only get one number out. Does that happen with this particular equation? Yes, it does. Every time I put a number in, I will take that number, I will multiply it by 5, and I will get a unique answer out of it, correct? Yeah. So this is a function. Okay, last question on this one. It says indicate if the relationship is a function, draw an input-output diagram, or if the relationship is not a function, explain why not. Well, we already said that it is a function on the previous page, right, or your previous part of the problem. This is a general kind of a direction that it will give so that it doesn't give the answer away to part C by saying it differently. You guys know what I'm talking about, right? Okay, so we're at the part where we're going to draw an input-output diagram. because it is a function. All right, so let me show you what an input-output diagram looks like. You may or may not have seen one of these before. It's going to look like a box. The input is at the top. That's in our case. Our rule is the name of our function, so it's rule g. That's the rule that we're following. And our output is g of n. I almost didn't leave myself enough space for that. Maybe I should make it just a little bit bigger. Okay, so it's coming out of the function. The diagram needs to describe what's going on. This is the number of words spelled right. And down here is your raw score. So if you can imagine that this is kind of like a machine, and in this machine, you put something into the top of the machine. Hang on, I want another color. So you put something into the top of the machine, and exactly one item comes out of the bottom of the machine. Okay? This is an input-output diagram. And they look like this all the time. There's no differences. Okay, this is a rare case right here where you don't see any language surrounding this particular equation, right? It doesn't say like the last one where it said numbers of words and raw scores and all of that kind of thing. So this would be an example of one where you're not going to have any language of units, descriptions of units with it. This says simply to calculate the following for the function. The first one says an output value when x is equal to -3. So if you'll remember from an algebra course somewhere along the way, what this means is that we are going to replace the x with -3 everywhere we see an x. You do want to be a little bit careful when you have exponents, and so what I do is I put parentheses around everything to remind myself. Now on the left-hand side, depending on how long it maybe has been since you've had any algebra experience, this notation is notation. It just means output. Okay, it does not mean the letter G multiplied by a number -3. Okay, parentheses are so bad in mathematics because they have so many different meanings. At least 3 off the top of my head I can think of. Multiplication, this function notation, and intervals. Oh, there's a fourth one. How about points, ordered pairs? It's terrible. It's terrible that we have so many different meanings for parentheses, but we do. And the meaning right here is not multiplication. It means y. The equivalent here is saying the output. So this is saying output is. So there's nothing to do on the left. It's just notation. However, on the right, we do have to calculate. One of the things that you need to remember to do is that when you square things, you multiply them by themselves, right? So the -3 here is -3 times -3, which gives you a +9. Okay, so that's why I want to be careful with my parentheses so that I don't end up with a wrong sign somewhere. So I have 7 times 9, which is 63. I have -2 and -3, which gives me +6 and then -3 for a grand total of what? 66. Now, you might be asking yourself, how much of that does she expect to see on my paper? I almost could have done all of that in my head. And some of you may not be thinking that. But those of you who are, I need to answer that question for you because it's a very good question, actually. This statement, I expect to see on your paper. That shows that you know what you're supposed to do with the -3. And we're going to be using that kind of notation throughout the entire semester. Okay? So if you've got an input, you're going to show that you're plugging it in. And then after that, all I really need to see is your answer. As far as I'm concerned, you can grab your calculator and it can do the multiplication, addition, subtraction. I don't care that you do that. This is calculus. It is not pre-algebra, because those are pre-algebra concepts, right? And they really are. So if you want to use your calculator to get to the actual 66, that's fine. Now B is a little bit more difficult because it is actually asking you for what? The input, not the output. So we're going to have some fun with a calculator here in a minute, but let's write down what this is actually telling us first. It's telling us that the g of x is equal to 2. So the place where g of x is, all of that gets replaced by 2, and then the right-hand side stays the same, like so. Okay, So there's several things you could do to solve this. Can somebody tell me what you, I'm not asking you to do it, just tell me what you could do to solve this. What are some options?
Factor it out.
Factor it. So we move the 2 over and we'd factor it. That'd be an option. What else would be an option?
Graph it.
Graph it. Definitely an option. That's actually the one we're going to go with here in a minute. There's another one. Oh, somebody said it. The quadratic equation, quadratic formula. You guys remember that? That would be another option, especially if it didn't factor, right? Yeah, it would. So all of those are perfectly fine. In general, we're not always going to be working in this class with quadratics. And if we're not working with quadratics, then the factoring option becomes less viable and the quadratic formula becomes completely unusable. Make sense? So graphical actually is the way that we can approach any of our problems and get at least an approximate solution. And for what we're going to be doing with calculus, an approximate solution with our calculator, and when I say approximate, what I mean is that we're not going to use radicals. I'm not going to write down my answer square root of 2 if there was an answer square root of 2. I'm going to write down the decimal for it, okay? So if that's our approach, then the best solution for us to be able to do all of our problems is to do it graphically, okay? So let me pause this right now, and let's see if I can get the document camera to cooperate for us. I'm going to show you, in case you don't know how to do this graphically, how you can do this graphically with the TI-84 or 83 calculator. Oh, there you go now. All right, so the first thing you're going to do is you're going to press y equals. If you have anything in here, go ahead and clear this out. If any of these buttons at the top are black, like they're darkened, then that means they're turned on and we want to turn them off. Okay, so these plot 1, plot 2, plot 3 should be off. So this is what it would look like if it was on. All you have to do to turn it off is to go up, arrow up to it, and press enter on top of it. So those should all be off for now. We will be using those later this semester, but not today. In the first side of the first line of your calculator where it says y1, you can put in the number 2 because that is the left-hand side of our equation. It's 2. And the second line, you can put in the right-hand side of our equation, which is 7x squared minus 2x minus 3. Everybody good so far? Okay. Because we don't have any reason to do anything otherwise, we're going to do a standard viewing window, which is a 10 by 10 and 10 by 10. Okay? So negative 10 to 10 on x and on y. So we're going to do zoom 6. 6 is standard, z standard. Okay, that first line that it drew horizontal, that was my line y equal to. That's why you saw it zoom across really fast. Simple and easy for it to draw. The second one's the quadratic that you saw, right? Okay, there's a couple ways you can use your calculator to figure out what those places are where they cross, because that's what we want. These two are equal to each other exactly when they cross one another. Okay? So I want to find this location right here and this location right here. I would suggest, or one option is that you could zoom in. So if we did that, we say zoom and number 2 and zoom in, and you just press enter, and you'll get closer. And you might be able to visually say, well, it looks like it's, and again, we're looking for the x value here. It looks like it's almost negative 1, because that's what these hash marks are, and almost positive 1 over here. And that's an approximation, right? So that's helpful. It's not a great answer, but it is helpful to be aware of. You do have a trace button right here. So you can press trace and you can go over there and you can get to what you feel like is a pretty close spot right there. You might be like, oh, look, it's not negative 1. It's about negative 0.69. And you can do the same thing on the other side. That's great. It has a little bit less error than just eyeballing it, right? But you still have some error because you don't know that you're exactly right on both of those equations at that spot, correct? So the third option here that is maybe the best option is that underneath your calc menu, do you see right here where it says CALC above trace? If you hit second and you hit the trace button, it pulls up the calculate menu. And what we're wanting in this menu is the one that says what?
Intersect.
Intersect. We want to see where they intersect. So this is number 5. So you can either press 5 or you can arrow down to the number 5. And it gives you some directions at the bottom of your screen. It says first curve. And so you can see at the top, right now, the curve that it's on is the y1 curve. So you're on the first curve, so you can just press enter. It says second curve, and you see that it already switched it to say y2, so you can just press enter. And then it says guess. And when it says guess, it doesn't mean that you necessarily have to put in a number, although you can. It just means you need to be kind of close to it on the graph. And we are. So we can just press enter as well. And when it does that, it actually gives us the answer at the bottom of the screen. How cool is that, right? And so we're going to write down 2 decimals of accuracy for this. So your answer for x, not y, we don't care about y, we knew y is 2. Okay, y was 2 because we actually put in y equal to 2. It's the x value we're looking for, negative 0.71. All right, we're going to do the same thing for the other intersection point on the right-hand side. Okay, so we're going to do second trace, number 5 for intersect. First curve, it says y1, so I'm good. Second curve, it says y2, so I'm good. But when it says guess now, I'm not where I need to be, right? So you could just press the number 1 because we think it's at about x equal 1. You can press the right-hand arrow and arrow over to where you think you're close. Now it looks like you can't even see your dot, but you can see where your cursor is, right? It's at a negative 0.26. So you're not really losing it. It's still just not there yet on the screen. And then it comes on up that curve. And now we're pretty close. Close enough anyway. Close as we need to be. We can press enter. And this one has an intersection that actually is x equal 1. So you have two answers. X equals negative 0.71 or negative 71 hundredths. And x equals 1. Those are our two solutions. Okay, so our values were x equals negative 0.71 and 1. And you don't really have to show any more work than just that. Your calculator did everything for you, right? Yeah, it did. So this is sufficient. All right, one last problem today. We're going to talk a little bit more about that notation. And you can see that they're giving you, again, different letters, right? P of M. P of M is the median sale price in thousands of dollars of existing one-family homes in area M in 2008. Okay, so M is an area, city, state, county, we don't know, but it's some kind of an area, it's a location. And P of M, it described at the beginning, is the value of the homes there. And they're using a median sale price. So if you know a little bit of statistics, you know what median is. I don't really want to go down that road today, but just know that this is somehow giving you an average. A median is one way of finding averages, okay? So what it's wanting us to do is to write function notation for this statement. So this statement right here is a verbal description. It says, the median sale price in Honolulu was $295,000 in 2008. That's the verbal description. And it's wanting us to write what the notation would look like for our function with that information. So the first thing I write is I write down P, and I put parentheses. And what is M? M is the area. So what area is this sentence describing? No, the area. What's the area in this sentence? Honolulu. Honolulu is the area that we're talking about. So we're going to write the word Honolulu inside of the parentheses. So now this is telling us the median sale price in Honolulu, or the median sale price of Honolulu, equals. And what does it equal? Yeah, it is 295. It's not 295, 000. Why not?
Because it states in thousands of dollars.
Right. Very good. This states that the equation, or the verbal description, or whatever you're using, is already measuring it in thousands of dollars. So when I write 295, I mean 295,000. It's like when I say 5'4", I mean 5 feet 4 inches. Right? Okay? So this is 295. That's it. That's all the problem is. It's just turning it from words into something that looks more like what you're familiar with in equations. And we're going to go the other direction here. This says P of M is the median sale price in thousands of dollars, same thing as before. And it says now to interpret with a sentence. So we're going to write out a sentence for what P Rhode Island equals 137.8 means. What in the world does this statement tell us? Okay, so we're going to start with that. The median sale price in Rhode Island. Okay, so that's kind of what the left-hand side says. And then what are we going to write next?
Is 137,800.
right, is 137,800. True, we could use the word was. Obviously, old data was. I'm not going to be too particular on your past or present tense of those words. That's not a big deal. But we do need one more thing. A dollar sign, right. We need the dollar sign at the beginning. $137,800. Does that make sense? Excellent.